on chapter 12 and 13. This is for you to practice a little bit before the midterm. Okay? So I will give you soon details about the exact date, but it will be next week. And I posted an assignment for you on chapter 12 for you to practice on chapter 12. Okay? Now we will continue. We will end the material of chapter 13 today and start to do problems. So last time we have seen together that in case of central motion, we will have a conical shape. Okay, we have a conic shape. So here we got last time that the general expression will be of the form 1 over r equals to 1 over p cosine theta minus phi plus 1 over the eccentricity times p. Okay, and then we said that when we compare these two formulas, we can detect the variables of our conic. So first, for P, which is the distance to the directrix, we have that P can be written as 1 over C. While concerning the eccentricity E is in a way to have 1 over EP equal to GME over H squared. So just when we compare these two relations, we get first that P, which is the fixed distance from the focus to the directrix, is given by P equals 1 over C, and the eccentricity of the conic section is given by E equals to CH squared over GME. Now, concerning the angle phi in general, when possible, we take, if we know that V0 is perpendicular, the initial velocity, if it's perpendicular to the distance from the focal point, from the focus point to P, then phi will be 0 because we will be on the axis of symmetry of the cone. In case it's we have something different, I will do a problem with you to see what to do. But in general, phi is 0. So in this case, theta represents the angle from the axis of symmetry of the conic to any position, any vector position OP. Okay? So now, if we consider this particular case, then phi will be 0. So the general equation in this case for the conic section will be 1 over r equals c cosine theta, where theta is counted from the symmetry line, plus GME over h squared. Okay? Now, what we will do, we will try to define what will be the different possible types of conic shapes. Okay? So this will depend, as we will see together, on the value of the eccentricity. So for example, if the eccentricity is 0, we get a circle. If the eccentricity is 1, let's say we get an ellipse, etc. Okay, so we will together derive these relations. The first type, okay, is for eccentricity equal to 0. For eccentricity equal to 0, then the value of C will be 0, and we will see together why. Okay, because if we apply the formulas we got together on the case of E equal to 0, and we replace C by 0 in the equation here, so if you replace here C by 0, you will get that 1 over R is equal to GME over H squared, which is constant. Then for E equals 0, I obtain a constant. And since R is constant, so it's a circular motion, okay? And we will develop together what will be the expression of the velocity needed. If you want to launch a satellite, for example, okay, you will launch it in a way perpendicular to the vector position. So this is the focus point. This is the point P at the initial state. If you give it a velocity perpendicular to FP, then you can say that this will be the symmetry line of my conic shape. Okay, and I will have that V is restricted at this point only to the theta component, because VR is 0, so I only have V theta. And you know that in general, in cylindrical coordinates, we define V as it's in two components, VR and V theta. VR is R dot, and V theta is R theta. Since we have here are constant, so r dot will be 0, and therefore at this point the velocity will be restricted to r theta dot. Okay. And in circular motion, at any point I will only have theta component, because in particular for a circular motion r is constant, so r dot will always be 0, and then I will only have a component along v theta and no component along u. Okay, so in this case the value v0 will be equal to r0 theta dot 0, and then I can say that the value of theta dot can be given by v0 over r0. Okay, now concerning the expression of v0, we want to get what will be the expression of v0 in this case. You know that we have derived before last time that for a central force motion we have that h, the constant h, okay, which is 2 times dA by dt, is equal to r squared theta dot. Okay, and r squared theta dot can be written as r0 times r0 times theta dot, and we know that v0 is r0 theta dot, so we can replace r0 theta dot by v, and then we can demonstrate that r0 times v0 can be replaced by r squared theta dot, okay, which is equal to h. Then if we take this equation, okay, we have that r0 square times v0 square over gm will be equal to h square over gm, and this means that v0 can be calculated function of gm and r0. Okay, so if I take if I simplify here the constant here, I have that v0 times ir0 equals to h. Okay, so if I take r0 to the other side, okay, then I can derive that in case of a circular motion, the relation between v0 and r0 is radical gm over r0. Okay, because as you can see here, in the case of circular motion, r0 is h square over gm. So by replacing r0 by its value, which is h square over gm, I can get the following relation. So we can deduce that if I want to know what is the required velocity to launch a particle and give it a circular motion, the condition will be that v0 should be equal to gm over r0. Okay, so now the next step will be to get what will be the launching velocity. For example, if I want to have another type of motion, let's say I want to have a parabola. Okay, so for the case of parabola, the eccentricity should be 1. So in eccentricity of 1 will give me the conic section of a parabola, and in case I have epsilon smaller than 1 and higher than 1, I will have other two types that you will see together. So if the eccentricity is equal to 1, then I have that ch square over gm will be equal to 1. And from here, the constant c will be equal to gm over h square. Okay? But now I want to see what should be the value of v0 in order to obtain a parabola. For this reason, I will replace in my equation v0 correspond to theta equal to 0. Okay, so at theta equal to 0, if I replace in the equation of the conic, this is the equation of the conic, 1 over r equals to c cosine theta plus gm over h square. If I replace theta by 0, I get that 1 over r0 is equal to gm, when you consider theta equal 0, cosine theta equal 1, so it's c plus gm over h square. Then you can, if you replace c by its value, which is gm over h square, you get that 1 over r0 is equal to 2 gm over h square. Okay, therefore we have that from this relation, okay, and knowing that h can be replaced by r0 times v0, I replaced h in this formula by r0 v0, then I get 1 over r0 is equal to 2 gm over r0 squared times v0 squared. I remind you that h is given by r squared theta dot. Okay, but as we said, since we are considering as the initial point, v0 is launched perpendicular to the radial to the position vector. This means that no VR at this position. So always when you eject, when you launch your particle perpendicular to the position vector, at this point, at theta equals 0, no VR, you have only v theta. So v theta, which is v0, can be written as r theta dot. And we know that h is r squared theta dot. This is why we can replace h at this point by r0 v0. Okay, and then from this relation here, we can see that to obtain a parabola, then I should have that v0 is radical of 2gm over r0. So you can see from here that if you eject with v0 equal radical gm over r0, you obtain a circle, and this corresponds to an eccentricity of 0. If you double the kinetic energy, because here v0 is a radical 2gm over r square, so if you put it square, you will get a double kinetic energy. If you double your kinetic energy, instead of getting a circle, you get a parabolic path. Okay, so at the same point, the parabola motion needs the kinetic energy double of the energy of the circular motion. Now, another type will be the ellipse. Okay, and we will derive together the equations of an ellipse. So first, the ellipse is characterized by several geometrical properties. First, you have, instead of one focus point, you have 2 points, because you have a symmetry here. Okay, so you have f1 and you have f2. You have perigee and apogee, which are, the perigee is defined as the closest distance between the point and the focus f1, and the apogee is characterized as the largest distance between f1 and the point. Now, the velocity at the apogee and the velocity at the perigee both are perpendicular to the position vector. So at these two positions, okay, I have the velocity perpendicular to the position vector, and then I can say that the velocity doesn't have a radial component at these two positions. In addition, for the ellipse, I can, if I define this distance to be a, so from the initial point to the center, if I take the axis of symmetry here, if I call this point O, so this distance from P to O is A, okay, and the distance from the focus point to O is C, then I can write that for any point on my ellipse, this is a geometrical property, okay, if I do PF1 plus PF2, I get 2 times A. Okay, and for the ellipse function, the ellipse function is given by x squared over a squared plus y squared over b squared equals to 1, where b represents this distance, the vertical distance. Okay, now since we demonstrated that for any point on the, we have a property that for any point on the ellipse, we have that PF1 plus PF2 equal to A. In particular, if I consider the point B, I can say also that BF1 plus BF2 equals to 2A also. Okay, and then since they are equal, then each of them, BF1 will be equal to BF2, will be equal to A. And therefore, I can relate the distance from the origin to the focus point, C, I can relate it to A and B by saying that we have in this triangle, okay, it's a right triangle. BF1 is A, and I can say from Pythagoras theorem that A squared, which is this distance. So let me annotate it for you. Okay, guys, شوي معلق الpointer. Let me tell you. Here you have this is a square. Okay, you have b square plus c square is equal to a square. So you can write the following relation that c square can be given by a square minus b square. Okay, and now for the ellipse, okay, I have the following relation. First, the general relation for any conic will be 1 over r equals c cosine theta plus gm over a squared. Just the condition is to take the reference for theta, the symmetry line. Okay, so now the perigee corresponds to the closest point to, this is the perigee point. It is the closest point to the focus, f1. Okay, so this is the point corresponding to the perigee, and this is the point corresponding to the apogee. Okay, so I can write. So here now it's better. Let me show you. So this is point. The point here. This point is corresponding to the perigee. Okay, and this one will correspond to the apogee. This point here. Okay, and then we can say that to calculate RP, okay, RP corresponds to theta equal to 0 because I am considering this is my reference line. Okay, so this is my reference line. Theta will be the angle between this line and the position vector. So here, this is angle theta. Okay, then I can say that at the perigee level, I have theta equals 0, and at the apogee level, I have theta equal to pi. So I can derive now the expression of RP and RA. So first, for theta equal to 0, I have that R is equal to RP, and then I can say that by replacing theta by 0 in my equation, I get that 1 over RP equals to C plus GM over H square. So the constant C of my conic, of my ellipse, will be 1 over RP minus GM over H square. And as I told you, at perigee and apogee, since the velocity is perpendicular to the position vector, then it can be written as V equal to R theta dot. And since H is R squared theta dot, so you can replace at apogee and perigee, you can replace H by R times V. So at perigee point, it's RPVP, and at apogee point, it's RAVA. Okay, so we can say then that C is equal to 1 over RP minus GM over RP square VP square. This will give us the value of C by taking 1 over RP into factor. Now, so this will give us the equation of the ellipse. 1 over R is equal to 1 over RP times 1 minus GM over RP VP square cosine theta plus GM over RP square VP square. So if in a problem, they just give you the perigee value and the velocity at the perigee radius, okay, R, then it's enough to know the equation of your ellipse. Now, also, if I want to know about RA, I have for theta equal 180 degrees, which is pi, I have the apogee distance, RA. Then I can say that 1 over RA corresponds to minus C because cosine 180 is minus 1. So it's minus C plus GM over H square. And if I replace C by its value, which I got function of RP, okay, then I can find what is RA. So 1 over RA will be 1 over RP times 2GM RP VB square minus 1. Now, since I know that H at the apogee is equal to RAVA, and at the same time it's equal to RPVP. So once you get RA, you can now calculate VA based on this equality, which is RA plus VA equals to RA times VA equals to RP times V. Now, in case of an ellipse, you know from geometry that the area of an ellipse is given by pi times a times b, okay? However, also you can write here the area in another way, because in central motion, we said that h over 2 represent dA by dt, which is the rate of area change. And then you can say that the period required for a complete revolution, okay, if I multiply this period by dA over dt, then I will get the total area, because by definition, the period will give me the time needed to complete the whole path, so I will cover the whole area. Therefore, if you calculated A and B for your ellipse, and you know the value of H, if you know RAVA or RPVP, then you can calculate the period required for one revolution by saying that if I take 2 over H to the other side, I get the period equal 2 pi AB over H. Okay? Is it clear until now? Do you have any question on this?
دكتور
Yes.
لو طلعت معنا ht over 2 عملنا لها integral.
لا مش عملنا integral. You remember last time هلا حارجع لك عليها بالفولدر اللي شفناه last time. Last time تتذكر وقت عملنا derivation للcentral force motion. اوكي؟ بالcentral force motion طلع لنا term انه نحن we derived the expression of dA over dt. خليني انقل على الفايل تشوف. اذا ما اشعتوا برجع بعمل share screen. يلا just one minute. Do you see برمت عندكم السكرين لتاني فايل؟
Yes, doctor.
Yes, doctor.
Okay. Look here. وقت عملنا derivation if you remember last time. Okay. وقت كتبنا هيدي الاكسبريشن بين معنا انه h هي r square d theta by dt. بس اذا بنعمل analysis ل r square d theta by dt, if you go back to this figure, okay, dA can be defined, يعني elementary variation in area can be defined as the area of this triangle. شفتوا هيدا triangle هون؟ This triangle عنده side length of r، وعندي هون السيجمنت لينكس فينا اعتبره لانه فيري سمول ارك ار دي تاتا. فانت اذا عندك تراينجل بدك تجيب الاريا تبعه بتعمل بيس تايمز هايت اوفر 2. فنعتبر هون لانه الانجل كثير صغير الهايت هي ار والبيز هي ار دي تاتا، فشو بيكون الاليمنتري اريا دي اي هي 1 over 2 ار سكوير دي تاتا. اوكي؟ And if you do dA over dt, and if you divide by dt the two sides, بيطلع لك انه dA by dt اللي هي rate of change of area is equal to half r square d theta by dt. اوكي؟ ونحن بين معنا هون انه h هي 2 times dA by dt لانه r square d theta by dt هي double dA over dt. So from here you can define the change in area dA over dt by h over 2. Okay?
يعني دكتور لو طلعت الفورمولا عملنا انه انتجرال dA over dt صارت معنا ht over 2.
عملنا طلعت معنا dA over dt، جبنا اول شيء what is dA، الاكسبريشن اوف dA، وانت تيطلع لك اذا معك dA كيف بتجيب dA over dt؟ بتقسمها by dt بس. اوكي؟ بيرجع انت بما انه عندك dA by dt constant، مثل ما اقول لك مثلا اذا انا بعطيك velocity، اوكي، وبقول لك وبعطيك التايم، كيف بتجيب التوتال لينث؟ مش تعمل v times t فتجيب